Hello everyone, welcome to Geeks for Geeks. In this video, we will learn how to sort the linked list of zeros, ones and twos. So, the problem statement says we have given a linked list of zeros, ones and twos. We have to write a function to sort the given linked list. Let's see some examples first. Given linked list 2, 1, 2, 1, 1, 2, 0, 1, 0. After sorting, output will be 0, 0, 1, 1, 1, 1, 2, 2, 2. In the second example, we have given a linked list 2, 1, 0, 0, 1. After sorting, output will be 0, 0, 1, 1, 2. Let's see the algorithm to solve the above problem. Traverse the linked list and count the number of zeros, ones and twos. Let the counts be n1, n2 and n3 respectively. Traverse the list again, fill the first n1 nodes with 0, then n2 nodes with 1 and finally n3 nodes with 2. This method traverses the linked list 2 times. Let's see the C implementation of this algorithm. The return type of this function is void. Since it will not return anything, it will only sort the given linked list. The function takes one argument, the head of the linked list. Inside this function, we have declared a count array of size 3 since we have only 3 elements 0, 1 and 2 and initialize this array with 0. Count array will maintain the count of number of zeros, ones and twos present in the linked list. Also a temporary pointer ptr is declared and initialized with the head of the given linked list. Now we count the number of times each number is appearing in the linked list. So we will traverse the given linked list and increment the count of 0 if we encounter 0, will increment count for 1 if we encounter 1 and will increment count for 2 if we encounter 2. Here we are using linked list element as an index of count array to increment the count of that particular element. Once we have updated the count, we will point the pointer to point to the next node. After the traversal, count 0 will store total number of zeros, count 1 will store total number of ones and count 2 will store total number of twos. Once we have count the number of zeros, ones and twos, we will again traverse the linked list. We will again initialize the pointer ptr with the head of the linked list and will also initialize the variable I with 0. Inside this while loop, it will check whether the count of current I is 0 or not, where I will be either 0 or 1 or 2. If current count of I is 0, then we will increment the I, else we will replace the data of current node with I and decrement the count of count I and update the pointer to point to the next node. Once whole linked list is traversed, the modified linked list formed will be sorted. Let's take an example to demonstrate the code. Initially, we have given a linked list 2, 1, 1, 0, 2 and a count array of size 3 which is initialized to 0. Means value of count 0, count 1 and count 2 will be 0. We start with the head node of the linked list. After traversing through head node, count of 2 will be incremented by 1, so value of count 2 becomes 1. After traversing second node, count of 1 will be incremented by 1, so value of count 1 becomes 1. After traversing through third node, count of 1 will be incremented by 1, so value of count 1 becomes 2. After traversing through fourth node, count of 0 will be incremented by 1, so value of count 0 becomes 1. After traversing through fifth node, count of 2 will be incremented by 1, so value of count 2 becomes 2 and our algorithm stops. Now we have got the final count array which contains the number of zeros, ones and twos in the given linked list. In this example, number of zeros are 1, number of ones are 2 and number of twos are 2. Since we have got the counts of zeros, ones and twos, we can now sort the linked list. Initially, since count 0 is not 0, so first node data will be replaced by 0 and count 0 will be decremented by 1. Now since count 0 is 0, we will move forward in the count array and will also move forward in linked list. Since count 1 is not 0, we will replace second node data with 1 and will also decrement count 1 by 1. Since count 1 is not 0, we will stay on count 1 and will move forward in given linked list. After that, we will replace third node data with 1 and will decrement count 1 by 1. Since count 1 is 0, we will move forward and will also move forward in linked list. Now we will replace fourth node data with 2 and will decrement the count 2 by 1. Finally, we will replace fifth node data with 2 and decrease the count 2 by 1. So finally our count array becomes 0 and our final modified linked list will look like 0, 1, 1, 2, 2, which is sorted. Time complexity of this algorithm will be O(n) since we are linearly traversing the linked list 2 times, which is equivalent to O(n). With this, we end our tutorial. Thank you for watching. Please leave us your likes and comments.